Hello, welcome back, students. Now, in the previous discussion, we have learned about the limit. All right, so what is the limit? Limit is actually the behavior of y when x approach just to a value c. All right, so we know that, all right, when the x is getting closer to a value c, all right, let's say the graph. So this is the point C. When the x is getting closer to C from the left and from the right, now what happened to the y? Okay, if the y is getting closer to the value L, so we say the limit of function fx when x approaches C is L. So basically, all right, the L refer to the behavior of y. Y is getting closer to L. Now, for this week, we are going to continue with differentiation. Now, in fact, this differentiation, we are going to discuss the differentiation for about 2 to 3 weeks. So, we are going to learn the techniques of differentiation and the application of it. So, for the first discussion on the differentiation, right, we are going to learn what is the definition of differentiation, or sometimes we call it the derivative. So the derivative is referred to the differentiation, right? So the derivative of a function, right? So is the whole process is called differentiation. So we are going to learn the definition of this. Right, so we are going to start with the graph. Now, let's say we have a graph here. Okay, so how do we actually find uh, the slope of a function like this? Okay, so let's start with some revision. Now, in the previous discussion, we know that if we want to find the slope of a straight line, okay, the slope referred to m. Okay, if we want to find the slope of a straight line, so the definition, it will be the difference of y divided by the difference of x, right? So to find the difference of y and the difference of x, usually we are going to take 2 points. Now, let's say I'm taking this point. Okay, so this point, it should be 11 and 6. So we have 6, 11 for this point. And we are going to take another point. So let's say another point is right here. So this point is uh, 3 and 5. So we are going to take these 2 points. We find the difference of y, which is 11 minus 5. So 11 minus 5, this is the difference of y. And the difference of x will be 6 minus 3. So in this case, we have 6 over 3. So the slope is 2. Okay, so basically, right, to find the slope of a straight line, we take 2 points. And, right, we are going to find the difference of y and the difference of x. And we further find the ratio, right? The ratio is actually the slope. Now, back to our discussion for the curve like this. Now, how do we actually find the slope for this curve? Okay, first, can we take 2 points to find the slope? Now, well, we find that we can't take 2 points. Why? Because if let's say we are taking this point, we are taking this point here with this point, right? So we can only find the slope for this line, but we cannot find the slope for the curve here. Okay, so in this case, where we are taking 2 points to find the slope for this graph, right, we are unable to find it because, right, the 2 points doesn't represent the curve. So what do we do? Now, there is one way we can do it, right? Now, let's say we enlarge the curve. Okay, so we enlarge the curve. So when we enlarge the curve, now we can actually see that as we zoom in, the curve now become a straight line, okay, or near to a straight line. Now, when we zoom in the curve, it become near to a straight line. Then now we can actually take 2 points. Let's say we take this point. This point is 1 and 1. Okay, and we can actually take another point very near to it. Let's say this point. Okay, this is let's say we take 1.01. Okay, so we take this point 1.01 and we further enlarge it. All right, so for this point, right, we have 1.01 and 1.0201, right? This is the y, and this point is 1, 1. Now, when we zoom in the curve, now we have a straight line. So we can use these 2 straight lines to find the slope. So what is the slope now? The slope will be okay, 1.0201 minus 1. This is the difference of y. And divided by 1.01 minus 1. All right, so this is the difference of x, right, which is 1.01 minus 1. So solving this one, we will get the slope is approximately 2. All right, so then we can actually use this method to find the slope. Now, actually, we can actually use these 2 points to draw a straight line. All right, so and we use the straight line to find the slope for this point. So let's say we use these two points, we draw a straight line. So you can see now, all right. So we have this straight line represent the slope for this point. Now we call this line a tangent line. All right, the tangent. This line is called tangent. Okay, we say the tangent. This line is the tangent for the curve at the point x equals to 1. All right, the tangent of y equals to x squared, the curve at which point? At the point x equals to 1. Okay, so now we can actually find the slope of the tangent, and the slope of the tangent is the slope of the curve at this point. So I'm going to write down because this is very important. So we are going to use the tangent to find the slope. So this is the slope of the tangent. The t refers to the tangent. So the slope of the tangent is actually the slope of the curve y equals to x squared at which point? At x equals to 1. Okay, so the slope of the tangent is the slope of the curve at a certain point. All right, so now this concept is called the first principle of derivative, or we say the first principle of differentiation. All right, so we are going to talk about the algebra part later. All right, so but before that, all right, just want to explain to you that now to find the slope of a curve, we can actually using two strict point, 2 points, when we zoom in and we draw the one straight line from these 2 points, and it's called a tangent, and we can use the tangent to find the slope of the curve at this point. Now you can see I keep mentioning that, right? This is the slope for this point only. Now it is because if we are looking for another point, let's say this point, right? When the x is 2, the y is 4, when we have this point, okay? So now let's say we zoom in to find the slope again. So when we zoom in again, now we can see that the curve become near to a straight line. So let's say we are taking another point here. All right, this is 2.02. Okay, and 4.08. So we have another point, 2.02 and 4.08. Okay, so let's take these 2 points to find the slope. So to find the slope, okay, so we first find the difference of y. So what is the difference of y? The difference of y is 4.08 minus 4 over 2.02 minus 2. So we have the difference of y, which is 4.08 minus 4. And we have the difference of x, which is 2.02 minus 2. Okay, solving this, we have 0.08 divided by 0.02. So we will get, right, the slope is approximately 4. All right, so by drawing a line, a tangent line, okay, we can actually find the slope as well, right? The other method is to draw a tangent line. So let's draw a tangent line. So when we draw a tangent line, we can actually find the equation is equivalent to 4x minus 4. Okay, so when we draw a straight line, so we can see that, so this is the tangent, this line is the tangent to the curve at the point x equals to 2. Okay, now as we can see here, now for this point when the x is 2, the slope is actually 4. Okay, so it's different from the purple line here. For the purple line, when the x is 1, all right, so the slope is 2. Okay, so from here, actually, we know that, all right, so at the different point of x, the slope actually different. So we say that the slope is changing, right, according to the point of x. Okay, so the slope is changing according to the point of x. When we have different value of x, the slope of the curve will be different as well. Okay, so now let's come to the algebra part. Okay, now, so for the algebra method, okay, now let's say we want to find the slope of a tangent line. Okay, so the fundamental operation is called differentiation. Okay, so the derivative is actually the slope, and the differentiation is the process. Right, now I repeat, what is derivative? The derivative is the differentiation, the slope, and the differentiation is the process. Okay, now, so the slope can be defined using this. Okay, now, what is this? This is actually fx plus delta x minus fx divided by the delta x. And we limit the delta x is close to 0. Now, let me explain what happened here. Okay, now, let's say we have a graph here. And this is the x, this is the y. So we have the function like this. Now we know that when we have x here, we substitute into the function. All right, this function is y equals to fx. So when we have x, we substitute into the function. We can find here, this is fx. Okay, if the x is 1, so this is f1. Now, let's say we take another point here. Okay, and the difference here, we call it the difference of x. Okay, so now, I hope you remember this symbol. This symbol is the difference of x. Okay, so the difference of x here says that, all right, so this is the difference of x. Now, so how do we label this point? We can label this point as x plus the delta of x. Okay, so the x plus the delta x, the difference of x. All right, so we have this point. Now, when we substitute this point into the fx, what do we get here? What do we get here? We will get fx plus delta x, right? So when we substitute this into here, so we get this one. Okay. So now, remember the explanation before this. We say if we want to find the slope for this point, what do? We are going to use these 2 points to find the difference of y and the difference of x. So how do we find the difference of y here? Now the difference of y here will be fx plus delta x, all right, this point, minus fx. This is the difference of y. Okay, so this is the difference of y. So the difference of y will be fx plus delta x minus fx. So this refers to the difference of y. And this is the difference of x. Okay, so this is the difference of x, so we just take the delta x here. Okay, now remember when we discuss about the graph, we also mentioned that these 2 points, it must be very close to each other, right? So we need to zoom in and very close to each other so that this curve can appear to be a straight line. Okay, so how do we actually show that these 2 points, they are very close to each other? So we use the concept limit. We say that we have to limit the difference of x here, this difference of x, it must be very, very small. Okay, this difference of x must be very, very small and approaches to 0. It means that it must be very, very small, as small as 0. Okay, so this limit here tells us that these 2 points, they are very close to each other because the difference is close to 0. Okay, so from here, we can actually take these 2 points, we draw the tangent line, and we find the slope of the curve at this point. All right, so this is the idea from the perspective of algebra. So let's consider the definition again. So the derivative is actually the slope. Okay, so it will be equivalent to, we limit the difference of x is very, very small, right? Then we have the difference of y divided by the difference of x. Now, all this provided that the limit exists, okay? And for all x for which the limit exists, f prime, okay, f prime is a function of x instead, right? So f prime is equals to something, something x. Okay, so now, so for derivative, okay, this symbol we read as f prime of x. Okay, so other symbol we use to denote the derivative will be dy dx, or y prime, or the difference of fx with respect to the difference of x, or we have the difference of y, right, with respect to the difference of x. Okay, so these are all the symbol for derivative, right, for differentiation. Okay, now the notation dy dx is read as the derivative of y, so the derivative of y with respect to x. Okay, so usually we will say dy dx. All right, so using the limit notation, we are going to write like this. Now, in the following discussion, we are going to use an example to describe how we actually use this definition, right, to find the derivative of this function. Okay, so first we have this function fx equals to x to the power of 3 plus 2x. So this function, right, is actually here. This is the function. Now, to find the derivative of the function, so we need fx, which is this one. We also need fx plus delta x. So we are going to proceed to find the fx plus delta x first. Now, how to find the fx plus delta x? So we are going to substitute this one here. So we have x plus delta x. Okay, so if this is x, this is x. So when this is x plus delta x, here will be x plus delta x cubed plus 2 times x plus delta x. So the input we substitute inside the x. Now with this, right, now we can actually expand this one. So when we expand this, we have x to the power of 3 plus 3x squared delta x plus 3x bracket delta x square plus bracket delta x to the power of 3 plus 2x plus 2 delta x. Okay, so when we expand this one, we have this one. And when we expand this, we have 2 times x plus 2 times delta x. Now, what are we going to do next? We are going to substitute this one, all right, into here. So this is fx plus delta x. So substitute into here. Okay, so we rewrite the, okay, write the f prime x again. So now we will have x to the power of 3 plus 3x squared delta x plus 3x delta x squared plus delta x to the power of 3 plus 2x plus 2 delta x. Now this whole thing now minus the fx. So minus the fx, we have minus x to the power 3 plus 2x. Okay, and divided by delta x. Okay, so when we subtract this, okay, so we can see here, okay, so x to the power 3 and x to the power 3, all right, because it's minus, so x to the power 3 minus x to the power 3, so we can cancel it off. And what else we can cancel off? We have 2x here, right? 2x and the 2x here. So 2x minus 2x, we can cancel off. Okay, so now the equation, the expressions now remain delta x. Okay, we have 3x squared delta x, 3x delta x squared, delta x to the power 3, and 2 delta x. Now, as we can see here, we can actually factorize out the delta x, right? Right, so we have delta x, delta x, delta x, delta x. So we can factorize out the delta x. So we proceed to factorize out the delta x. So we have 3x squared plus 3x. All right, we still have 1 delta x here. We still have 2 delta x here. And plus 2. All right, this delta x has been taken out. Okay, then we have right, this one divided by delta x. Now, as we can see here, then we can actually eliminate the delta x. Therefore, all right, so when we have the limit, all right, the delta x is close to 0. Now, what happened is that, remember in the previous discussion, we say to find the limit, we can actually substitute the value inside here, right? Okay, to find the limit, we use the substitution method. We substitute the 0 into the delta x. So what we can see here, if we substitute 0 here, this term will be 0. And when we substitute this value here, this term will be 0. Okay, so in this case, okay, so all right, after we substitute this no more, then we will have 3x squared plus 0 plus 0 plus 2. So this will be the derivative of this function. Now we are solving this using the first principle method, right? So this is called the first principle method. And right, when we use this method, we actually draw 2 points on the graph and we find the slope using the 2 points. Okay, let's revisit again what happened, all right, when we actually use the first principle to solve this. So we are going to substitute, right? Substitute x plus delta x into the function. So we will have, right, x plus delta x to the power 3 plus 2 times x plus delta x. All right, substitute this one into the fx, so we get this. So minus the fx, which is this function. And further to that, we actually expand this. So we have this one. All right, and plus 2x plus 2 delta x minus x to the power 3 minus 2x. So then we simplify x to the power 3 and 2x. Okay, so when we simplify x to the power 3 and the 2x here, so we have this one, and we factorize the delta x. So factorize the delta x, so we simplify with the denominator. Finally, substitute 0 into the delta x. Right, so these two terms become 0. All right, so we have 3x squared plus 2.